Welcome to IP version 6. So what is IP version 6? IP version 6 is a better modified version of IP version 4. It consists of 32 nibbles or 8 hectares of binary bits separated by colons and written in hexadecimal form. For example, as we can see, here are some terminologies to be familiar with. So we see that a bit is either 1 or 0. We have nibble. A nibble is 4 bits, which, for example, we have 1010, and in hexadecimal form we have OXA, where A is the 4 binary bits. And next we have octet or a byte, which is 8 bits. And we can see the example here of 8 bits, and in hexadecimal form we can see it as OXC9, where this represents C9, C being represented by the first 4 bits, which is 1100, because this is 8 and the next one is 4, the fourth and third position of the nibble. So remember, nibble is 4 bits, so the fourth position is 2 raised to the power of 3, because the first one is 2 raised to the power of 0, second is 2 raised to the power of 1, third is 2 raised to the power of 2, and the fourth is 2 raised to the power of 3. And that's why we have 8 bits plus this next one is 4 bits, that's 12. So 12 represents C, because 10 is A, 11 is B, and 12 is C. Then the other nibble, we can see the fourth position here is 8, and the first position here for the nibble is 1, because it's 2 raised to the power of 0. So 8 plus 1, that's why we have 9 here. So that's how we convert from a nibble to hexadecimal form. And then we have hextet, which is 16 bits. And we can see the example here, which is 4 nibbles. Octet is 2 nibbles, and hectet is 4 nibbles. A is 1010. Why? Because we have 8 plus 2. And the second one is the same thing, A. The third nibble, so the first one is 0, the second one is 2 raised to the power of 2, that is 4, then we have 0, 0, and that's why we have 4 here. So the last nibble is 0110, and we can see the first bit of that nibble is 0, so it doesn't count. The next one is 1, and there we have 2 raised to the power of 2, that gives us 4, and the next one is 2 raised to the power of 1, which is 2, so 4 plus 2 is 6, and that's why we have 6 here. So eventually this hectet, which is made up of 4 nibbles, has these 4 nibble hexadecimal characters as AA46. So we can see at the bottom here how we were able to convert from decimal to hexadecimal, from the 10th character to the 15th character. We can see it goes from A, B, C, D, E, F. So we have an example of an IP version 6 IP address here, and we can see that it has network and host portions just like the IP version 4. But this time we have by default 64 bits is assigned to the network portion, and 64 bits is assigned to the host portion. So this is the recommended allocation by default. We have 4 hectares here. Remember, we said it's made up of 8 hectares, which is 32 nibbles. So we have 4 hectares in the network portion and 4 hectares in the host portion. And each hectare is made up of 4 nibbles. And that's why we have 1, 2, 3, 4. And if we come back, we can see that a nibble is 4 bits, an octet is 8 bits, and a hectet is 16 bits. So we have 16 bits per hectet, which is 4 nibbles. And here we have 8 hectets, which make up the IPv6 address. And we can see that the network portion is made up of 4 hectares and the host portion is made up of 4 hectares. So there is a way to shorten the IPv6 address when you have zeros involved in the IPv6 address. So to shorten it, we can see that the 2001 remains the same colon, then we omit the 0, and that's what has been omitted here. Then we have DB8, then we omit the 3 zeros from here and we bring down the 2, then we omit the 2 zeros and we bring down the 8 and D. And that's what we have done here for the network portion. And the host portion is the same. We have all zeros, so 4 zeros, so we bring down only 1 zero and omit the first 3. Then we have 4 zeros, we omit the first 3 and bring 1 down. Then we have 00 A5, so we omit the zeros and bring just A5, and we have 52 F5, which we brought down. So this is the shortened form of the IPv6 address. So we can also further shorten it again with the double colon. We notice that in this place we have 2 zeros that are separated by colons and are immediately close to each other. So what we do in that case is we use a double colon instead to replace that. So this double colon represents these zeros that have been omitted. So at the end of the day, we have this as the shortened form of the initial IPv6 address. So IPv6 devices must be in the same network portion for communication to take place without a router or a layer 3 device. So this is the same as we saw in IPv4. And in this example, we can see here, these two devices are found in the same IPv6 network. So there are different IPv6 addresses used for IPv6 networks. So some of these include the first one, which is IPv6 Global Unicast Address, which is used for global communication. It's also called a public address. And we can see the example on the table below. The global unicast address is what we have here with /64. Then we have IPv6 link local unicast address, which is used for local communication, or it's also called the local address. And we can see the example on the table below. Link local unicast address, which starts with FE80 and is /10. So it means that the first 10 bits are the network portions, and that's what we have here as an example of that. Then the next one we have is IPv6 loopback address, which is used for troubleshooting IPv6 stack on a network card. The syntax here, which is :1/128. So it's all zeros, then at the end we just have 1, which is what we have here. Then we have IPv6 unique local address, which is created to be used for local communication, which is similar to the private address in IPv4, but this time it doesn't involve the use of NAT, and which is network address translation. So, or the syntax is FC00 with CIDR notation of 7, which means that the first 7 bits are the network portions. So these are the 4 main types of IPv6 addresses that are in use. So when we find out the IP configuration in our laptop or our device, we realize that we are given an IPv6 address, as we can see set up here, and we also see the link local IPv6 address that we also talked about, including the IPv4 address and the subnet masks for that, and also default gateway in IPv6 as well as in IPv4. So let's take notes whenever we search for the IP configuration of our host devices.